Okay, let's start with the LTE system architecture. It is because the LTE system architecture is basic to understand the mobile communication system. Yeah. So I think you are already somewhat familiar with LTE system architecture. However, let's check again the key features of LTE system architecture. Okay. Yeah. First, let's study LTE system architecture overview, and followed by LTE Radio Architecture. And next, LTE Evolved Packet Core Architecture, and various in LTE, and LTE Control Architecture. Okay. LTE architecture is consisted of 3 domains. First is the access domain. Okay. Access domain. Yeah, access domain is this part. Access domain, main part of the access domain is E node B. E node B is actually a radio access point for the end hosts. And the central part of the architecture is evolved packet core domain. We call EPC. Okay. EPC consists of MME and serving gateway and the pass gateway. Actually, MME is for control and management of this LTE system, and serving gateway and PDN Gateway is their roles are related to transport the packet data. So here, solid line means pass over data. Okay. Is solid line. Data pass. Okay. Actually here, the IP network, internet core, internet. So here directly it connected to internet core. But the MME as a center of control. So this dotted line means the control signal travels this like this. Okay. So MME is the central part to control signal messages. Okay. So, and last part is control domain. This is control domain. So control domain consists of HSS, IMS, and the PCRF. We will study one by one. Okay. Let's see the LTE system architecture overview again. Access domain first. (3GPP) is a third generation partnership project. 3GPP architecture in 3GPP radio architecture, two networks elements were defined. Node B and radio network access controller in UMTS system. UMTS terrestrial radio access networks we call UTRAN. But 2G system, the base transceiver station and the base station controller in GSM H radio access network. Okay. So difference is in UTRAN, two elements are node B and the radio access controller, network controller. So in GSM, two elements are BTS and BSC. In LTE network, these two elements combined into one element called E node B. Yeah. Yeah. It's the two elements are combined into one element that the access domain can be simple. The main reason for this simplified architecture were reducing complexity and reducing latency and reducing costs, while increasing data throughput and signaling rate. Okay. Next, let's see the evolved packet core domain. Okay. Yeah. EPC. So EPC contains the three functional elements. First, MME, and second, serving gateway, and PDN Gateway. So EPC contains three elements. MME resides in control plane of EPC. So control plane carry control signals to control and manage the LTE networks. Data plane provide a path for data transfer. So anyway, the MME performs user authentication, mobility management, tracking area list management, handover, and bearer management. This data plane management, data path management. Serving gateway. Serving gateway resides in the user plane. It's the data plane. The user plane is same as data plane of EPC. So user plane packets traverse through serving gateway in uplink and downlink. Also, serving gateway function as a local mobility anchor. That is able to forward the packet during handover. So during handover period, serving gateway does not change. Okay. Serving gateway remains as an anchor. Okay. Next, PDN Gateway. PDN Gateway resides in the data plane of EPC. PDN Gateway function as global internet protocol mobility anchor point. So PDN Gateway allocate IP address to user equipment. Also, PDN Gateway provide interface toward the packet data networks, PDNs. That's why the name of gateway is PDN Gateway. Okay. So PDN Gateway connect to internet through PDN Gateway. PDN Gateway also policy charging enforcement function for detection of service data flow, policy enforcement. So the authorized packet only pass through PDN Gateway. Yeah. Also, the flow-based charging. PDN Gateway detect how many packets or user equipment send to internet, and the charging is based on the how many packets user equipment send to the internet. Okay. Okay, third element of LTE system is control domain. Here, three building blocks. Control domain contains three building blocks. IMS, home subscriber server, policy and charging rules function, PCRF. Here, HSS is important for you. So, home subscriber server is the main data storage for all subscribers. Okay. So for security, home subscribe server maintains all the secret key for all subscribers. And so MME consult with the HSS when a user wants to use LTE network. So MME consult with the HSS whether MME permit the user equipment to use LTE networks or not. Okay. LTE Radio Architecture. So LTE Radio Network Architecture is constituted only with evolved node B called E node B. Okay. Different from 2G and 3G systems. Radio access networks has only one element, that is E node B. function of E node B is as follows. E node B function as a radio resource management point. Such as radio bearer management, handover control management, and all forms of radio control. Also, E node B deal with encryption of user data packets. E node B also responsible for selection of MME. So E node B, when user try to access LTE networks, first E node B assign a proper MME. Also, E node B route the user packet toward the serving gateway. Also, transmit responsible for transmission and the scheduling of paging data. Here you can see the protocol architecture of E node B and user equipment. Okay, first, UE and E node B physical layer is same. This is user equipment. This is E node B. And above physical layer, there is a MAC layer. MAC layer is medium access control, similar to MAC in Ethernet. Above MAC, there is a RLC. RLC control radio link. Above RLC, PDCP exists. PDCP means packet data convergence protocol. You need to understand user equipment is different from the 2G, 3G equipment. User equipment in 4G system only handles IP packet from application layer. Sometimes we call this kind of concept is all IP networks. From the user equipment, PDCP support to handle only IP packet. Okay, PDCP. Okay, above PDCP, there is RRC. RRC is radio resource control. This frequency management. Radio resource control. Okay. Assign carrier frequency. Okay. Above RLC, you see MME. MME has a NAS protocol. So user equipment here is NAS protocol. Okay. Anyway, only control signal. Control signal. Signal is control signal use this MME and a NAS and this NAS. NAS is network access stratum. Okay. Okay, the LTE okay, I think it is UE interface. Connect E node B with UE. So here, this interface. Also both control and the user plane. Control data and the user data. Okay. So user data is passed this way. This way. Control data pass. Control data is this way. So the control plane connection is signaling radio bearer. This interface works as user plane connection, works as data radio bearer. Next interface is S1 MME interface. This is S1 MME interface. Okay. S1 MME interface. So S1 MME interface connect E node B with the MME for control plane. So the S1 application protocol performs the following functions. Transmit the non-access stratum NAS signaling between MME and UE. And delivering paging message to UE. And the management of bearers to be established for UE. Next, the S1U interface. Is connect E node B with the serving gateway. Okay, this interface. So this interface uses GPRS tunneling protocol. Running on top of UDP, which carries user IP packet to serving gateway. Also, there is X2 interface. This interface. This is E node B and E node B. Connect different E node Bs with each other. Serve as both control plane and user plane interface between different E node Bs. So important is, during handover, E node B change. So during handover procedure, this X2 protocol is used. Also, GTPU protocol in user plane handle data. So here, between E node B and the serving gateway, link interface, physical link, L2, IP, UDP, and GTP. GTPU. This is user data protocol stack. LTE interface, physical, MAC, RLC, PDCP. This is control plane protocol stacks. UE, E node B, and MME. This interface, physical, MAC, RLC, PDCP, RRC. Okay, here, this interface between E node B and MME, physical layer L1, L2 layer, same as TCP IP network, IP. This is SCTP, S1AP protocol. And above there is NAS protocol here. So NAS is non-access stratum. S1AP is S1 application protocol. SCTP is stream control transfer protocol. Okay, let's see LTE Radio Protocol one by one. Okay, radio resource control, RRC. So RRC handles all necessary control signaling for radio operation, including management control and handover command. Packet data convergence protocol, PDCP, covers ciphering also IP header compression. So use of header compression is not mandatory, but quite essential in order to achieve good voice capacity, as otherwise the IP header overhead takes quite a large part of capacity in case of a large amount of voice user. Yeah, internet phone needs a large amount of voice data, to voice packet. So if we compress the header field of each packet, the volume of packet data can be reduced. Okay, and the radio link control. Okay, control retransmission is not normally used for voice. Okay, media access control. So mapping and the multiplexing of logical channels to transport channels, as well as taking care of physical layer retransmission. So okay, medium access control. Last element in LTE radio protocol is physical layer. Physical layer covers channel encoding, decoding, error detection, modulation, demodulation. Yeah. Also power control and then multi-antenna operation. Based on orthogonal frequency division, multiplexing access is used for downlink. Single carrier frequency division multiplexing access is used for uplink. Okay. Okay, EPC is evolution of the General Packet Radio System, GPRS. Okay, as you know, the GPRS is used for mobile data service. GPRS is the first packet switched mobile data service introduced in European telecommunication standard ETSI 3GPP release 97. In GPRS, there is a dedicated core for packet switched data service. Two elements. Serving GPRS support node, SGSN, and the Gateway GPRS support node, GGSN. Yeah. SGSN, GGSN. So here, so evolved packet core for 2G, 3G systems. For 2G case, BSC is interconnected to SGSN. Yeah, this one. Also, in 3G system, RNC is connected to a system. But LTE system, okay, this E node B is connected to serving gateway or MME. Okay. 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 Packet switch core in GPRS use the global system for mobile GSM and the UMTS access technologies. The EPC used for GSM, UMTS, LTE non-access technologies to provide the IP connectivity and the service continuity in mobile networks. So MME can be seen as evolution of SGSN. That is the control plane function in GPRS. Okay. Also, the serving gateway associated with the SGSN user plane function in GPRS. PDN Gateway is global Internet Protocol mobility anchor point, equivalent to gateway GPRS support node in GPRS. Okay. Here you can see how EPC was evolved from 2G, 3G system. Again, okay, the evolved LTE system is here. The 2G system need this equipment, okay, and connected to here and here. Okay, in 3G system, okay, also need this system and this system. This is for control. Okay. Now let's move to MME, Mobility Management Entity. MME. Its main control and management entity for mobility in LTE networks. Also, MME keeps track of state and the mobility of UEs that are registered on network. MME acts as a gatekeeper, handling user requests for network access, handling user requests for network access, and setting up and tear down data sessions, data paths. Also, MME handles authentication of users on networks, as well as basic authorization. Authorization is permit to use network resources. MME communicate with the HSS to get security information for authentication kitting the UE. UE can authenticate the network as well. Okay. Also, MME select what serving gateway, what PDN gateway will be used for given session. Then the primary responsibility of MME is first deals with keeping track of UE location and state. This is the function of evolved mobility management. Next function is evolved session management, ESM. ESM deal with creating actual data session. Okay, mobility management entity, some other tasks. NAS signaling and security. session mobility management, including intra-LTE between LTE system, intra 3GPP mobility. Okay, 3G users change. When 3G users change, it's the base station. We also paging control and execution, tracking area list management, inter-node signaling, roaming, local inception for signaling traffic. This is a local interception for signaling traffic, control signaling traffic. Then the MME lets the operator to know where its user located, the location data. Serving gateway. Serving gateway is responsible for user plan gateway for LTE radio networks, inter E-node B handovers. Okay. Between two other E-node B, the handover and the handover take place, the serving gateway function as user plan gateway for LTE networks. Also, 3GPP mobility interface between SN and the serving gateway. Responsible for user plan gateway for inter 3GPP mobility. So relay traffic between 2G, 3G system and the PDN gateway. Yeah. The traffic 2G, 3G system from 2G system pass to serving gateway and the PDN gateway. Also, a single UE can be served only one serving gateway at any one time. So the serving gateway anchors the user. This means the user does not change serving gateway at any one time. Also, serving gateway receives instruction from MME to set up and tear down sessions for UE. This means set up and tear down control of sessions. So the handles user IP packets between PDN gateway and E-node B. Also act as a middleman for signaling between PDN gateway and MME. Middleman for signaling. Functionally, serving gateway is IP router with the support for mobile specific tunneling protocol, GTP. Yeah. Serving gateway. Some other task of serving gateway. Assist eNode B during inter-eNode B handover. Also, downlink packet buffering and the initiation of triggering of paging idle mode UEs. Transport level downlink uplink packet marking, local interception for roaming, charging for data roaming. Okay. Next, let's see PDN Gateway. PDN Gateway provides a user equipment with access to external packet data networks, internet. This is important by assigning an IP address to UE. So PDN Gateway assign IP address to UE. Functionally, PDN Gateway is an IP routing and forwarding entity. If a UE has multiple data sessions to multiple PDNs, packet data networks, UE can be connected to multiple PDN gateways. Let's see some other task of PDN gateway. Bearer management. Policy charging enforcement function, accounting and offline online charging support for data, packet filtering, local interception, user plan anchor for mobility between 3GPP and non-3GPP access systems. 3GPP, non-3GPP access systems. Okay. Okay, EPC has interface and protocols. First, the S1 interface, defined for control plane between MME and the serving gateway. Use GTP-C protocol. S5 interface. This is defined for control plane and the user plane between serving gateway and the PDN gateway. This provides GTP-U protocol to provide GTP tunnel per bearer for the user plane. GTP-C protocol to provide GTP tunnel per user for control plane. This is for data plane. Next, SGI interface. This is a control and user plane between P gateway and PDN internet. This uses IP packet forwarding protocol in the user plane. DHCP and dynamic host configuration protocol and radius diameter protocol in control plane. Okay. Let's see the PDN connections via IMS and internet both. Okay, here internet user can connect this way PDN gateway here, IMS, and this way connect to this internet. So additional default bearer with a new IP address. Okay, this is two different IP address. Created and service are offered via multiple access point names. Okay, figure shows how here UE has two simultaneous PDN connections, one for IMS, another for internet. So different access point names may be supported by different PDN gateways. So IMS access point names might be supported only one limited number of PDNs, where the internet access point names might be supported by all other PDN gateways. Okay, bearer in LTE. Bearer is a logical packet transmission path set up at UE, eNode B serving gateway, and the PDN gateway. In LTE, end-to-end bearer are realized by EPC bearer. So this is whole from UE and peer-to-peer entity. This is end-to-end service bureau defined. We define this as end-to-end service bureau. End-to-end service bureau can be divided into two bureaus. EPS bureau from here to here, from UE to PDN gateway. And here to here is external bureau. EPS bureau can be also divided into two different. This is ERAB bureau, S5, S8 bureau. Also ERAB bureau, this is radio bureau, and this is S1 bureau. Okay, from E and B, and this is S1 bureau. From here to here, this is radio bureau. Okay. So here, ERAB bureau. Okay, this one. Combination of radio bureau and S1 bureau. Radio bureau and S1 bureau. Okay. Okay, control architecture. IP multimedia signal system IMS. IMS was originally intended to be the voice signaling and the delivery platform for IP-capable networks such as Universal Mobile Telecommunication System and LTE. That provide the service for voice and the multimedia over packet switched networks. This is IMS was developed by 3GPP organization to support IP-based multimedia sessions. IP multimedia subsystem core is based on the session initiation protocol SIP and the real-time transport protocol RTP. Okay. SIP is used to create control sessions. SIP function works on core server control function, which play important role in IMS authentication. Session initiation protocol. So the device can register their presence with the IMS networks, receive messaging based on specific event of time they subscribe to, initiate and receive a real-time multimedia session. Okay. So the IMS has many elements: HSS, AS, SC, SCF, IC, SCF, PCSCF. Okay. CSCF is responsible for call session control functions. CSPF. PCSPF is proxy call session control function. ICSCF, interrogating call session control function. SCSCF, serving call session control function. AS, application server, home subscribe server, policy charging rule, PCRF. Okay, let's see PCSCF in IMS. This is first contact point for users within IMS. So all SIP signaling, session initiation protocol signaling traffic from UE will be sent to PCSCF. Following 5 unique tasks is assigned for PCSCF. SIP compression, IPsec security, interaction with the PCRF, control of network address transit, not here. Not because the LTE network use private IP address. Okay. ICSCF. 3 main tasks for ICSCF. Obtaining name for next hop. Okay. Last, SCSCF. SCSCF is responsible for handling registration process, making routing decision, maintaining session state, storing service profile. Okay, control plane and control domain has HSS. HSS is important for authentication. Act as database of subscriber information that can be inquired by MMEs to determine permitted service. Okay, to allow service. So the HSS hold security key information for all SIM card in mobile network users. Okay, the smartphone has a SIM card. So HSS has the information that what MME in what networks a SIM is registered on can inform all MME. That's the PCRF. Creating, tearing down voice bearers act as bridge between IMS and the EPC domains. For example, setting up required EPC bearer for new voice session.